Okay, so here's some examples, a little bit about crisscross predicting ionic compounds. Up till now, we've been splitting them into ions, such as barium is a +2 because it's a metal. It'll give up its 2 valence electrons. Well, oxygen is a non-metal. It'll accept those 2 electrons, and so it's a 2- because it gains electrons. And then figure out how many of each we have. There is a simpler way or faster way to do this, and it's called the Criss Cross Method. And so it really makes it super fast to predict the ionic compounds as long as you know the charges. So let's go ahead and look. So as we know, an ionic compound is neutral over R, all, which means the plus charge of the cations plus the negative charge of all the anions will equal 0. So if the charges of the cation and anion don't add up to be 0, okay, then you can crisscross. And what does that mean? It means if they don't have the same charge, such as this one here, sorry, new pen, as this one here, where barium, just one barium is a 2+, oxygen is a 2-, then you know you have a ratio of 1 to 1. You only need one of each. So our formula with this. But what happens in a situation where iron, such as iron, is a 3+, oxygen 2-, and then they don't add up? So a 3+ plus a 2- will get you still a 1+, so it doesn't add to 0. So what are we going to do in that place? And that's when our crisscross comes in, and I'm going to show you a couple things, such as this iron. So I would take iron 3+, and I would put over on the other side oxygen 2-, and what's going to happen is, to make it even, you can think that you need 2 of these and 3 of these. But what you can do instead is you can take just the number, not the charge, not that it's negative, and send it over here to iron. So I'm going to need 2 iron atoms, get rid of that charge, and 3 oxygen, which we already know. And it's just a quick way to determine what the formula would be, such as you would need 2 iron to 3 oxygen. And it's just a shortcut to figuring out ionic compounds. This only works for ionic compounds. This does not work when we get to covalent. Okay? And then naming those ions, remember, a cation, use the element name as is, such as lithium will be lithium ion. And the anion, you're going to add that IDE. So we're going to practice that as well. Okay? All right, so let's look at a couple. So we have barium and we have oxygen. Okay, so barium. Okay, here we go. Barium. Barium sits here in our second column, or what we would call our 2A column. It has 2 valent electrons. So it's going to become a 2+, right? Because remember, this is a 1+, this column, all these will become 1+ ions, 2+ ions. We skip over the transition metals. We'll get to those later. These will be a 3+. These we'll just leave alone for right now. These would be a 3-, 2-, and a 1-. So these columns make those anions, okay? So barium is in, can also remember, this is the 2A column, so it has 2 valent electrons, and so it's a 2+ is barium. So barium, we're going to write down the cation is barium. Barium is a 2+. Okay, the anion would be oxygen, because oxygen is a nonmetal, so it's going to make an anion and gain those electrons, gain negative particles, and it is in the over here, it is in the 3. This is, let me just label these, the 3A, the 4A, the 5A. This is the 6A and 7A. So it is in the 6A column, which means it's going to gain 2 electrons to get to the 8A column. Okay, 8 valent electrons. So we have oxygen, it's going to be a 2 minus. Okay, and notice they are the same, so we're not going to worry about those. We don't need to crisscross these since they have the same charge, so we just need one of each. So it'd be barium O, and you're going to write the name here, barium, and then the anion gets changed to oxide. Okay. All right, let's look at our next one. We have magnesium and chlorine, so we're going to look at magnesium. Again, magnesium is a metal, so it's going to lose those 2 valent electrons in 2A to become a 2 plus. Chlorine, let's go take a look at chlorine. Chlorine's over here, and it's a non-metal, so it's going to gain those electrons. So to get to 8A column, it needs to gain 1 electron, so it's going to become a 1 minus. Oops. So chlorine is going to be a 1 minus. And notice now they're not the same. So this is when we can crisscross. So we're going to do magnesium 2 plus, chlorine 1 minus. Not going to worry about those charges. The 1, we're going to bring it over here. We only need 1 magnesium ion. And we're going to need 2 chlorine. To make our now final compound, magnesium, we don't write a 1, just like in math, chlorine 2. And then we're going to name it magnesium. Chlorine is our anion, so it gets changed to chloride. Okay. How about the next one? Calcium and nitrogen. So let's look up calcium. Calcium is going to be, it's on the left side, it's a metal, so it's going to be our cation. It has 2 valent electron, our group 2A. So it's going to lose those 2 valent electrons to become a 2 plus. Nitrogen is over here. It is a non-metal. So it's going to gain electrons on the right side. So it's going to gain electrons. It wants to become like a noble gas. So it'll gain 1, 2, 3 to become a 3 minus. And notice they are not the same, so we will use our crisscrossing method. So I'm just going to rewrite them over here. Okay, forget the charges. Okay, we're going to take the 3, send it over here. We're going to take the 2, send it this way. And our final formula will be 3 calciums to 2 nitrogens. Okay, and then we're going to name it calcium because it is my cation. And then nitrogen, it's my anion, so it gets changed to nitride. Okay. All right. On the back side, you're going to practice this, okay? And you're going to practice this 3 different ways, A, B, C. So I'm going to do an example of each. So the first one is fill in the chart by balancing charges between these ions and cations to form neutral compounds. So we call this, what you're doing, monatomic compound. Mono means 1, so 1 atom. So it's 1 atom for each. And you'll see why we call it monatomic, because we're going to deal with transition metals, and then we're also going to deal with something called polyatomic. Okay. So what you're going to do is you have sodium here and you have chlorine, and you're going to crisscross them. So again, they are the same. So you only need 1 of each. And then you're going to write the formula into here, okay? If you need more space to crisscross this, please make sure that you have another piece of paper to crisscross this. Now I will be using one, okay? All right, how about this one? All right, so we've got sodium. And we have sulfur. And notice sodium has a +1, but sulfur has a -2. So it's not the same. So this is where we can begin our crisscrossing. So I'm going to go ahead. I'm going to do it on my scratch paper here. Or you can do it in your notebook because you're going to staple this over the top. So feel free to do it that way. So Na+ and an S2-. Remember, we're going to forget, okay, about those charges. I forgot my one, okay? And then we're going to just take the 2. We're going to need 2 sodiums to 1 sulfur. And so my new formula would be 2 sodiums to 1 sulfur, okay? Let's go ahead and do fluorine. So this is a +1, that's a -1. They are no different, so you're just going to need 1 of each. And you would just write it, sodium fluoride. For my next one, this is a +1, this is a 2-. They are different. So I'm going to go ahead and do my crisscrossing. Again, forget about the charges, just worry about the actual numbers. The 2 will go over sodium. I will need 2 sodium ions to 1 nitrogen. And we never write the 1, so it's Na2N, sodium nitride. Okay. The last one is sodium and oxygen. Oxygen is a 2- anion. Sodium is a +1. They are different, so I'm going to go ahead and do my crisscrossing. Okay. Forget about the charges. And then you're going to take just the numbers to decide how many of each. So you need 2 sodium ions to 1 oxygen again. So Na2O, sodium oxide. Okay. And then you're going to continue that for the other cations here. Okay. In B, you're going to write the ion for each of the resulting formulas. Okay. Which means aluminum, this is just practicing. Okay, and we're going to go all the way across. So you can see sodium, you wrote is the cation. It's a Na +1. Sulfur is the anion, S2-, and then you're going to combine them just like we did up here. And you're going to do the same here. So aluminum, okay, aluminum here is here, okay. It is a metal. So it's going to lose its 3 valence electrons because of group 13 and it's in 3A. So it's going to make a 3+. Okay. Well, chlorine, if we look on the periodic table, is a nonmetal. So it's going to gain those electrons to become like a noble gas, to be able to gain that to get 8. To be in here, we're going to gain 1 electron to become like a noble gas, and it's going to become a 1- chlorine. They are different, so I'm going to go ahead, okay, and I'm going to crisscross those because they are different charges. So I have my aluminum 3+, my chlorine 1-. Again, don't worry about the charges, just take the numbers. So I need 1 aluminum to 3 chlorine. So I'm going to need 1 aluminum atom to 3 chlorines to make a neutral compound. So now we're aluminum, don't write the 1, and chlorine 3, aluminum chloride. So that's for group B work. For group C, you're going to be given the formula here, and there's something wrong with each of the following. Explain the mistake and write the correct answer, okay? So for calcium oxide, it says I need 2 calciums to 2 oxygens. So why is it wrong? Well, the first thing we have to figure out is the charges on my ions. So remember, our cation is always written first, positive before negative. So we have our calcium, and so we're going to check that out. So calcium is here, a metal. It's in group 2A. It has 2 valence electrons. It's a metal, so it's going to lose those to become positive. So it's going to have a 2+. Calcium is a 2+. Well, oxygen is going to be my anion. It is my nonmetal, so it's going to gain electrons to become like a noble gas. So to become a noble gas, it has to gain 1, 2 to become a 2-. And if you notice, they have the same charge, 2+, 2-. So you really only need 1 of each, which this is correct. But remember, one of our steps in finishing it is making sure that it's like a fraction. So one of the things we have to do is if I can divide these subscripts both by the same number, then I'm going to go ahead and do that. So you really only need 1 of each. You don't need 2 of each, okay? So what is wrong is this formula. is not reduced to simplest form, which means just like a fraction, because that's really what we're doing. We're doing a ratio of calcium ions, oxygen ions. You want to make sure that it's down at the lowest. So it should be written here, calcium oxide. So you're going to look at these. There is something wrong with each of these formulas, and then tell me what's wrong, and then tell me how it should be written. Okay, if you have any questions, please let me know.